sorry, let's just say that again. Welcome to the Cumulocity and Option Simplifying the Adoption of Edge Analytics webinar. I'm Philip Hooker, Director of Strategic Programs at Cumulocity, and I'm delighted to be joined today by Jörg Palm, Chief Marketing Officer, and Martin Kroom, Senior Director, Product Management and Strategy Adoption. As the Internet of Things is maturing, we've found that more consideration needs to be given to why, where, and how the decision-making capabilities of computational analytics are used in IT solutions. Early analytics models, which simply detected a measurement threshold being exceeded, have now evolved to far more interactive models which can predict a future state. With these analytics models being developed in multiple points throughout the solution, a more holistic approach is required to managing their lifecycle. This approach needs to recognize that the models need to be rapidly created, continuously evolve, and be mass deployed in a controlled, industrialized manner. Firstly, I'd like to provide a brief introduction to Cumulocity. Cumulocity was born in an innovation initiative inside Nokia, which is focused on making carrier-grade network management systems applicable to the requirements and economics of the evolving machine-to-machine market. The organization grew rapidly through its successes and won numerous industry awards before being spun off, but still backed in Nokia's 2012 reorganization. Today, Cumulocity serves over 100 enterprise customers using over 1,000 tenants and supports over 2,500 developers around the world. Cumulocity strives to remove the complexity and cost from IoT and allow the benefits to be exploited rapidly, comprehensively, and securely by all organizations. We offer a fully featured Internet of Things application enablement and device management platform product, which covers 80 to 90% of the requirements of most customers out of the box. The remaining 10 to 20% can be easily developed using our open APIs, plugins, and application integration. Our IoT platform is inherently carrier-grade for security, reliability, and availability, and is both device and network agnostic. It can be deployed across 20 global cloud hubs on 5 continents, or on premises in the customer site, or as a hybrid of both. At Cumulocity, we feel the Internet of Things is about partners, and Cumulocity is continuously leveraging and building out its leading partner network. As a horizontal platform provider, we are involved in many vertical markets and continuously bring the ingenious, innovative approaches in one market to other markets we are working in. Our IoT platform is white-labeled by many partners around the world. We have devices from many manufacturers pre-integrated and open source agents for the most common device platforms. Our breadth of network, application, systems integrator, and independent software vendor partnerships helps us solve the customer's common problem, enterprise digitalization. I'd now like to hand over to Jörg to introduce Option.
So, hello everybody. That's Jörg Palm from Option, and I have the pleasure to give you a quick overview about Option and Cloudgate and our clever edge computing device. So, the company has a serious track record. We are there for longer than 30 years. We really have probably one of the strongest track records in wireless in Europe, and we are recognized for our development capabilities worldwide. In the field of all the skills you need to make great gateways and associated devices, you see there a list where we are really outstanding, and also deliver custom-made designs and specific products. So IoT is a buzzword, as we all know. but probably it's fair to say that it is some 30, 40 vertical segments. And the point of that slide is that you don't look in all to those verticals. The point is that we recognize how many verticals it has, and that all those verticals have no single standard. There is no single standard in IoT, and our Cloudgate hardware responds to that very well. So how does it look like? In the center, you have our Cloudgate, and the first differentiating point is the modularity with its expansion cards. We have an array of probably some 30 out-of-the-box, high-quality cards, which allow you to get the hardware connectivity in all those different verticals, well, out of the box, at decent quality and at good quality and attractive price points. There's a provisioning server for the first connection behind, but more important for the edge analytics is LuvitRED, and Martin will elaborate about that later in 2 minutes. The point is, with that software, you can do edge analytics on an industrial-grade Linux gateway. It is a Linux computer which has been well designed for the purposes of IoT. If a customer then says, well, great, I might leverage LuvitRED, and most do, but they might want to add something, or say, no, we have our own application and it's already ready, and you know what, it runs on Linux, so why should I throw it away? Well, you don't need it to throw it away. You can run anything which can run on Linux, can in principle run also on our gateway. In case the customer doesn't have that application yet, there's an SDK available to help him to build one if he really wants. But probably a bit more differentiating is the HDK, where we have a significant number of customers who appreciate that they can make their own cards. So they leverage the existing platform and appreciate everything what's there, and they are glad that they don't need to take care about that because it's there. But then they develop with the help of our HDK their own card because they find it important to differentiate a bit on that. But it's not, well, you also can say, like with our engineering capabilities, it happens rather frequently, let's say at least once a month, that a customer says, I have a very specific requirement, can you make that card? And further, I take the full Cloudgate ecosystem. So to put it a bit in a nutshell, before Martin shares with you the real how it works, the Cloudgate is a modular platform. It is high quality, and it covers most of IoT use cases. LuvitRED is a flexible, visual, programmable, configurable software. And by those nodes and what Martin will show you, you have an enormous speed and you program also with quality. Those blocks just prevent the typical bugs because you can't make them due to the nature of the interface. You could say something which in the past might have cost 50K to Accenture, with great respect to Accenture, a bit skilled person can do in an afternoon or in 2 days. It is an open system, so anything which should run on that Linux computer can run on that Linux computer. And it is accessible via other management platforms, and probably the integration we have achieved here with Cumulocity is a very complete one and a very comfortable one for the customer or the one who wants to operate this solution. The industrial capabilities are perhaps represented by, it is one of the few boxes which out of the box works between -30 degrees Celsius and +70 degrees Celsius, which is really harsh environments. So you find our box in the boxes in the Arab area in a metal cage in the middle of the sun, and the box works. Oops. The gateway is available in 2G, 3G, a 2G, 3G version, a 4G version, and Ethernet connectivity for cases where mobile backhaul is not possible. But certainly for the 3G, you have 3 different versions for the different regions, as 3G is not a global standard. It's more or less 3 standards, right? It is a flexible architecture. You will see that when we show to you. You can decide what logic you want to execute on the gateway, so do edge computing, and what logic to execute centrally on the Cumulocity platform. And we think that is the right way. We shouldn't be religious about that. The customer and the use case should decide where the logic fits or to what proportion the logic is either at the edge or at the cloud. Our device is cost effective. I mentioned HDK, SDK available. And also important, if you are a customer or you serve a customer who operates worldwide, it is important that you have the necessary certifications, the certification authorities regulated, but it's also important that you have certification from the major operators. And our Cloudgate has all that. Well, one final sentence is, in case somebody wants something significantly smaller than the Cloudgate with all its, let's say, Swiss Army knife capabilities, still, this is a device where you can pilot very fast and prove the business case. And once that is proven and you want to go into big masses, Option is the company which can make tailor-made devices in case not all the functionality offered by Cloudgate is needed. So that's the general introduction. And Phil, please pass on to Martin.
Great, excellent. Thanks, Jörg. So what we'll do now is actually go through a kind of a use case to actually look at analytics here. So why analytics, and why is analytics so important? So IoT is a technology that allows the monitoring and control of remote assets, be they cars, street lamps, or industrial heating, ventilation, and air conditioning systems, the so-called HVAC systems. These HVAC systems are often critical to a building and its inhabitants, none more so in those areas of the world where the natural climate is very damaging to human health. The systems themselves are often hidden and out of sight, either in rooftops or in basements. The HVAC equipment suppliers aim for all users to be delighted by their experience of the service. A perfect climate in every room of the building, all throughout the year, not too much to ask for. However, sometimes the customers can feel a little let down with large temperature variations throughout a building, and strangely the coldest season inside the building being during summer. The demands of these customers can be grouped into 3 main areas, which are quite reflective of how all equipment providers understand the customer situation and striving for customer delight, delivering the service as close to 100% availability as possible, so the customer can be reassured of its availability, and reducing both its own and the customer's operating costs by only using the resources which are necessary when they're necessary, and saving money on energy usage. Now, an IoT solution is built through connecting devices such as this HVAC, managing their data, and extending the service. To fully manage the environment, the connection has to be to both the asset via industry protocols like Modbus or BACnet, and also to climate sensors around the device and in the building to provide a data stream with a user view. Analytics comprises of a number of ways to process the device data to enable automated decision making. Common analytics requirements include detecting a divergence from a normal power versus output usage profile. Also facilitating a remote device configuration and avoiding a field service call. Prediction of likely future faults and alerting of field service personnel for repair scheduling, which may be necessary in some very hard to get to places. And also having local autonomy of operation and a minimization of communication costs. So if there's no communication at all, the whole service can still work. A simple IoT solution might just have a few components and would benefit from analytics processes in a number of places in the overall solution, both in the gateway, but also in the IoT platform. Now, the complexity comes when the number of devices increases and the analytics model becomes more intricate. So, how does this simple model scale? Or how can it scale without also increasing the complexity? All analytics models are built around data and evolved through iterative cycles of improved business understanding, data understanding, modeling, and in-life evaluation. These analyst models provide numerous outputs and can be used to manage the performance of each asset individually, as in a single HVAC unit on the roof, also used to manage the performance of all assets within a process, thereby limiting the scope of a single asset's possible states so that it best serves the overall process. For example, the process will be slowly ramped down for a predicted terminal fault in an asset rather than being stopped, which actually can have a larger impact on the overall process. And also, analytics can be used to collate and assess the performance of multiple solution components and provide an aggregate view of the information, how they've been used in life. These models then operate at different layers in the overall IoT solution. For example, a simple temperature threshold that's been exceeded could initiate a local corrective action on the asset. This alert might be propagated up to a process rule, which could then assess other connected assets and make a best decision about using them. These alerts and their cause might actually then be captured by another rule assessing component performance. These layers are commonly processed by different components in the overall IoT solution. We're using edge analytics on the IoT gateway, using stream analytics on the IoT platform, and using some representation of analytics reporting on the IoT platform also. Now, in an immature analytics environment, like many IoT cases, the iterative process has complications before it has begun. The common ones here are that there is little true business understanding of the situation and little or no historical data to set the direction. This creates two main problems. The first one is how to build and continuously evolve the model effectively. And the second, how to manage the deployment complexity at scale to get these models out into the field. Now, tackling the second problem first. Cumulocity's IoT platform contains a fully featured device management with a inventory for each connected device and asset. The device management can be used to deploy the analytics software and models to devices and keep track of their notifications. These notifications are associated to the current configuration, configuration state of the device. This allows tracking. So when a change is necessary, the devices can be updated and all the notifications through the sometimes lengthy transitions are associated to the active analytics model actually on that device. Associating notifications to that active analytics model improves the decision making of the analytics at the next level, as it knows what decision process was taken to create the actual notification itself, and therefore what action it should take. And then tackling the first problem. Option Cloudgate LuvitRED is a device-based visual analytics flow creation environment, which radically speeds up the creation, validation, and industrialization of analytics models. Martin will demo this shortly. So how does this fit together? So very briefly, the solution can be walked through in 3 steps. So firstly, LuvitRED is used to build an analytics model on one Cloudgate. The flow can then be actually uploaded to Cumulocity very easily, and that flow can be deployed toward filtered devices. So I now hand over to Martin to take us through the live demo.
Hi there. So thank you, Philip. What I'm going to do is try and relate some of what Philip's been saying to a small demo of how LuvitRED works in that scenario. I'm going to limit this to really the temperature aspect of this. However, LuvitRED is perfectly capable of covering both the backnet and Modbus sensing, or Modbus and backnet data collection, and in fact more. So we're going to look specifically at how we might get some sensor data in from a temperature sensor, transmit that sensor data to the Cumulocity platform, then do a little bit of simple analytics on the actual Cloudgate, looking at thresholds and alarms, and then finally look at how we might start to control what's actually happening within that analytics flow, within the flow that's running on the Cloudgate from the Cumulocity platform. So perhaps, Phil, you can give me control of the presentation. Thank you. Okay, we're going to log into the Cloudgate and start to get to the LuvitRED screen. Now, LuvitRED is a plugin, what we call a plugin into the Cloudgate UI. Any application that's developed using our software development kit can plug into our UI in this way. In fact, quite a bit on the UI can actually be changed by the application. So in this particular case, when I click here, it starts to be LuvitRED that's actually controlling what the customer is seeing. We're using exactly the same tools that we use for our own applications as we provide to customers. Now, if anyone's seen Node-RED, then LuvitRED's user interface may look somewhat familiar. Essentially, what we did was start with Node-RED, but in the back end of Node-RED, we've completely replaced with a execution engine that makes things a lot faster and using less memory. So we can run this on a very lightweight platform and a more cost-efficient platform, and also a more power-efficient platform. We've also made a lot of changes to the node sets to focus them in really on the IoT space and on specifically the B2B IoT space, and added some software stacks which are more complete. So what I'm going to do to start with is start looking at how this kind of works, particularly from the perspective of someone who hasn't seen Node-RED and hasn't seen any flow-based programming environments in their life. And then we'll go into the specifics of the temperature sensor. So in LuvitRED, everything is controlled by nodes, which you can pull from this palette on the left-hand side here onto a design space in the center. I'm going to pull a couple of very, very simple nodes, an inject and a debug node. What the inject node does is generates a message, and the message is flow down these wires that I've just connected these two nodes with. Now this UI is running inside my browser, but when I press deploy, it actually goes to the CloudGate, and the CloudGate is serving the web pages which make up this UI. So I'm directly doing this on the CloudGate. Now, what this is going to do, the inject node actually generates a message, and the debug node makes that message come out into this debug pane over here. So this is not going to do much. It's just when I click here, I get a number. Now, what is that number? Well, each node has a configuration pane. I can double-click the node and load the configuration pane. So, for example, I could set that number to something like a random number, and then I can just deploy that, and now I'll get a different output with some kind of random number. And essentially, these are inputs and these are outputs. Now, we also have nodes that can actually do functions and process things and process the numbers or the contents of the payload of these messages. So first thing I'm going to do is try to get the sensor data from the sensor to the debug node. As you saw in my demo setup, I have a CloudGate LTE device with a wireless sensor card in it, which operates on sub-gigahertz and in fact has a Wi-Fi card in it as well. And then I have a wireless sensor, and I'm going to start reading data from that sensor. So I drag a sensor node on to the design space. I configure exactly where the card is, what type of card it is. And in the case of these sensors, I need to add a sensor ID, which identifies the sensor to the gateway. I just link up the sensor to the debug node, press deploy. The gateway will initialize itself, and it's now waiting for the sensor. I'm going to switch the sensor on. And you can see now that it's detected the sensor, it's detected what type of sensor it is and that it's active, and it's started to output the temperature measurements. Now, you're just seeing here the payload of the message, but each message can contain multiple different pieces of information. In fact, this message behind contains things like the voltage level, the signal strength, and everything behind that sensor reading. Obviously, if the sensor was a different type of sensor, like a temperature humidity sensor, then you might get a table of information out here with two values in it rather than getting just a single value. So now we want to take that value and put that onto the Cumulocity platform. So we have an extensive set of nodes which cover the Cumulocity functionality. I'm going to deal with a few of those today, but if you want to get more details, Phil at the end will give you a URL of a much longer demo of exactly how Cumulocity works with LuvitRED. So the first thing we're going to do is we're going to put a measurement node down here, which allows us to transfer a measurement to the Cumulocity platform. I'm going to link the two, and then we need to do a bit of configuration. First thing we need to do is set up the URL and address of the Cumulocity platform. We're using the default Cumulocity hosted platform here, so we don't need to change anything. I've just enabled push, which allows me to push stuff to the CloudGate. We support both the long poll and also polling type approach of getting data down from the platform. We also support the Cumulocity automatic provisioning, which means that we don't actually need to enter any passwords or usernames or anything of that sort at this point. We can just provision automatically with the platform, and you'll see that working in a moment. I also need to put a snippet which describes the temperature measurement that I want to send up. I'm going to call it, say, an HVAC temp. And this is a custom snippet, which is how Cumulocity platform models data. And we're saying that we're going to get this value of this snippet from the payload of the message, of the incoming message. Done that. Deploy. And you'll now see that I'm actually getting an error message. And what it's saying is that my CloudGate isn't actually registered on the Cumulocity server. So I need to go back to the server and register that serial number on the Cumulocity server. So let's go to the server. So I go to the device registration pane in the server. I enter in the device. And now the Cumulocity platform is going to wait for the next time that the Cloudgate connects, and the Cloudgate tries to connect again, and it's now offering me an accept button. The Cloudgate LuvitRED is still not attached to the platform because I haven't authorized it yet. I press accept. If we go back to this pane now, then you'll see this change to being started, and now the real time is online, and the temperature measurements should now be starting to go across to Cumulocity there, and then we've got one measurement going up to the Cumulocity platform. So if I go back to Cumulocity, I can go into all devices. We will have updated the inventory of the device, so not only are you getting the actual application data, the measurements, but you're also getting all the things which you would require for device management, things like the signal strength and quality, which operator I'm connected to. We also offer a whole range of other control functions which allow you to manage the software that's on the device, the firmware, the radio firmware, the application firmware, upload and download flows to the device, upload and upload logs from the device, and do control and configuration of the flow. Let's look at the measurements. So we should have a few measurements in now. I'm going to change this to no aggregation and the last minute. And we'll put that in real time, and you can see that we're starting to get some measurements coming through. If I wrap my hand around the temperature sensor, we wait for another, you can see it starting to go up there in measurement. Now say in our scenario with the HVAC, we really, this is a normal situation, 23 degrees or whatever is a normal situation. We really don't want this temperature, whatever it represents, to go above 30. And if it does go above 30 degrees, then we would like to get an alarm onto the Cumulocity platform. We actually don't really need the ongoing measurements until we get to that state. There's no point in wasting data on a sim plan if we don't need to get this data through. So we don't really want that data. So it's very simple for us to start to add logical nodes to the flow, which are actually doing a little bit of processing in the middle. So at the very simplest level, we're just going to add a switch in the center, and we're just going to say, if the message payload is greater than 30, then send it to output 1, otherwise don't do anything with it. And we also want to report an alarm, so let's pick up an alarm node. I'll put the alarm node down there. The alarm node, we need to do a little bit of configuration on it, so we need to just tell it what's the platform. We need to give it a type, so HVAC over temp, and maybe some default text, HVAC temperature port 1 high, or something like that. And maybe this is quite a major event that's happening. Actually, a lot of these are changeable in the message, so the incoming message can change some of these elements, and we'll see that happening later. I just wire that up. And deploy it, and start to put my hand around the sensor. So the sensor is active again. And you can see the temperature is starting to rise. It may take a couple of measurements for it to get above 30 degrees. My hand isn't that warm. It really isn't that warm. We're choosing a high temperature. Oh, we're nearly there. Up to 29. And there we've got 30. And you can see now that our measurement count has gone to 1. We're starting to send measurements, and we also got an alarm that's going through. Now, the problem with this setup is obviously that we're generating a message here, but we're also generating a message here. So we're getting actually an alarm every single time that a measurement goes up. And again, that's kind of a waste of bandwidth. And perhaps we only need to get one temperature alarm through. And you can see our temperature HVAC over temperature. We've got all of the details of that alarm. You can also see that it's been generated several times there. So what would be nice is actually to be able to have this alarm so that we only generate one alarm, and that can demonstrate also some of the kind of functions that you can add into LuvitRED. So we're going to replace this switch node, and we're going to replace it with a function node. Now the function node really actually allows you to start programming within LuvitRED, and I'm not going to go into the details of programming, apart from to mention that LuvitRED is programmed in Lua, which is a very simple scripting language which anyone with basic knowledge of JavaScript or Python would be able to program in, and even a non-programmer would start to be able to do basic things with fairly simply. Let me leave that for the moment. I'm just going to cut and paste a program into this. And what this program is doing is pretty much the same thing that the switch node was doing, with a few bells and whistles. The first thing we're checking is the message payload more than 30, which is what we were doing, greater or equal to 30. And we're also checking, are we in an alarm state? Okay. If we aren't in an alarm state, then we're going to set ourselves into that alarm state. And setting a variable in this way will allow us, every message that comes in, we'll see this variable, and we'll be able to, so it's a kind of state for the node. The node stays in this state. Then we take the message and we clone the message, and so that we can send out a payload with a custom event text, which is just saying HVAC temperature exceeded, now at, and with the value. And then finally we send two messages out, one out of one output and one out of the second output. So we need two outputs to this function node. And then finally, otherwise we just send the normal temperature message and we don't send the alert message. And then finally, if we're in alarm and we're below 30 degrees or below 30 degrees, then we basically just come out of the alarm state. And you can see we're also doing a few things to update the UI so that you can see what's going on. Now, what I first need to do is wire those two up and deploy that. I'm also going to go and make sure that we don't have any active alarms here from our previous flow. Yeah. Clear those out. And we started to get the temperature messages, but we're back to 24 degrees, so I'm going to have to do my heating it up again, which hopefully can do faster. And as that's heating up, yeah, there we go. And you can see now that we're into alarm state. We have one measurement through. There's an alarm count of 1. I'm going to wait for the next measurement. You can now see we've got two measurements and only on one alarm. And we're also starting to get some reported. Now, this could definitely be used at this point, a function of this sort to create a message, which would then, for example, use either our Modbus node set, which is capable of polling and writing Modbus registers, acting like a Modbus gateway, acting as a firewall for Modbus, exposing points on the Cloudgate as Modbus points, and our equivalent BACnet stack, which also allows all of those things, plus some extra stuff that BACnet allows, things like change of value reporting or notification event reporting, discovery and device discovery. And also, we can function as a BACnet device and be visible to a building control system. For example, say there was a local building control system, these temperature measurements, we could make those available for that as well. All of this could be integrated into this flow and would then allow, say, some control function to trigger on the basis of the alarms that are happening here. If we go back to the platform, refresh my page here, you'll see that I've got the alarm and the HVAC temp exceeded now at 30. And I've only got one of those. Okay. Final thing I wanted to show you is a little bit of sort of giving you some ideas about how LuvitRED can allow you to control from the Cumulocity platform what's actually happening inside the flow. For that, we're going to use a node that's called config. and I'm also going to need a response node. What we're going to do here is actually get the config of the sensor ID and send it to the flow from the Cumulocity platform. Why is that important? Well, each site has probably got a different sensor on it, and these sensors each have a different separate ID. So you don't really want that as something which is static within the flow. So we're going to link this up. I'm also going to link this to a response node, which basically just confirms back to the Cumulocity platform that the config has been properly applied. There could be situations where the config isn't properly applied, and you want to make sure that the Cumulocity platform understands that operation failed. I'm also going to remove the sensor ID, and I'm just going to tell the config node which Cumulocity platform node to use. I now deploy that. And you can see that we're inactive. There's no sensor ID because it doesn't know what sensors should be used. Okay, I'm going to go back to the Cumulocity platform. Refresh the page. And I've got a configuration tab now. I can just put the sensor ID into that configuration tab, save here, configuration has been saved, and you can see now that the monitor sensor here, and I have a cellular connection to the Cumulocity platform, so this is updating over a cellular connection to Cumulocity's server. You can see that essentially what happened was a message was produced here with the number of the sensor. It's in fact the message is a copy of whatever is in that config window. That came into the monitor sensor node, which interpreted it as a sensor ID, and it's now set sensor ID. If I switch the sensor on, then we're now configured and we're back to our working flow again. And that concludes my little demo.
Excellent. Thank you, Martin. So if I reclaim the presenter role. So we've run through things a little bit more efficiently than we did this morning, which is great. And now we have an opportunity essentially to open the floor to questions that you can actually submit via the chat window. So you're, Martin, and myself are here to receive your questions. So if we've got the remaining hour, but if we kind of finish sooner, we can actually sort of close sooner if you like. But any questions you have about LuvitRED, about Cumulocity, about the combination, about the solutions, about analytics, please submit those now. So whilst you're sort of writing away, so I've got a question for Martin. So I know Martin, obviously using sort of Cumulocity and LuvitRED, we can actually deploy the configuration. Is it possible to also easily deploy the flow? Would that be working in a similar way?
Yeah, actually in the Cumulocity configuration pane, we've used the configuration snapshots, which are available there, to implement flow download. So basically what you can do is you can take a snapshot of the flow, and that's just taking a snapshot of the flow. And then you can propagate that flow to another device. So you can just download it. Or you could have, mostly what customers seem to do is, and it's the best way of doing it, is you have a golden device that you work everything out on your prototype device, and then you have your test devices, you propagate it out to your test devices, and then once you're sure that everything's working well, then you can propagate it out to all of your devices. And at that point, the flow will automatically be downloaded to the Cloudgate and reloaded, restarted in the Cloudgate.
Brilliant, excellent. So once again, if you have any questions, send those through to me, so Philip Hooker, on the chat. So also, Jorga, I know you said there's one of the features of Option Cloudgate is its kind of hardware flexibility and customization. So obviously the device is sort of fully flexible for different protocols already. So Modbus, BACnet, as Martin said. So what types of things are people actually defining their hardware for at the moment?
It's extremely varied. Is the answer. It can vary from everything from internal own protocol with their own interface with perhaps some kind of specialized connector that wants to be used for a specific thing, even something as basic as serial, to different types of wireless protocols, Zigbee, Bluetooth, all of these things which we support through LuvitRED, to wireless M-bus, there's a variety of different wireless protocols which are in operation, to adding functionality such as very specific GPIO, frequency counters, or some kind of hardware interface of that sort. It's extremely broad in range. In fact, what we find is that, it's never quite right in a lot of cases. It's the kind of the 20% at the end of M2M which makes it very difficult. The hardware is never exactly right, and so therefore having this ability to just adapt it with these flexible adapters really makes a huge difference to the speed at which one can get a prototype deployed and get a business case proven to be able to go quickly into production.
Great, excellent, thank you. So we haven't received any more questions at this time. So what I'll just fast check. So what I quickly do. So lastly, so thank you for your time. So if you require any more information, either about Cumulocity or options. So for Cumulocity, so contact myself, Philip Hooker, at sales@cumulocity.com. Or for option, please contact Jörg Palm at sales@option.com. We also have a wealth of information on both the Cumulocity and option websites. We've highlighted sort of four key ones here. So there's a kind of a large amount of information about sort of connecting different devices, assets, and actually using the platform on our developer center. So it's cumulocity.com/devcenter. Also, we have the Cumulocity view of kind of integrating Cloudgate into our platform and on our devices guide as well. There's a lot of information about the Option Cloudgate and actually integrating it, in extending it on the Option Cloudgate Universe site. Also, so Martin highlighted before, so there's a more in-depth video of actually using LuvitRED. So there's a long URL here, but I think if you just go to YouTube and do a search for Option LuvitRED, so Cumulocity node, it'd actually pull up this video, and you see Martin go through a lot more stages and a lot more things in depth about LuvitRED. So finally, I think it's now time for us as presenters. So thank you for your attention and your time. So we'll be posting the video online sort of shortly, and actually sending you out a link to receive that. But if you have any more questions, please feel free to get in touch, and also check out the documentation. So thank you for your time today.
Thanks, everybody. Bye.